Okay, that's better. Right, okay, so horses for courses. This is basically picking the right bit of hardware for the right tool. I'm just going to really cover workstations, so I'm looking like Threadrippers and APUs and laptops and stuff. We obviously do loads of other stuff, clouds and everything, but if you want to know more about that, just come and talk to us. Obviously what happened, the pandemic, people working from home, software as a service became more prevalent, people want access everywhere, everyone wants their designs now. If anything, because of shortages of other stuff, people want to have a redesign or something really, really quickly. So that's basically led to a lot more stuff of people using laptops or having high-performance computers at home in the home office, which is good for us because we have solutions in both of those. So Threadripper Pro is a processor, currently has 64 cores, 128 threads. The example here is Chaos Group. Chaos Group is a rendering application. So earlier on we saw one of the people presenting about using VRED. This would be great for rendering stuff. So those images you saw of the Lotus, this is the perfect platform. And that's not my view, that's Autodesk VRED team's view. So they use them, they actually use this type of stuff to make the stuff go faster. We also optimize. Basically, Threadripper Pro became prominent because of the media and entertainment audience. People were rendering stuff for movies and stuff like that. But we actually optimize stuff for SolidWorks and PTC. The performance is there. But the best thing is now we're actually doing optimizations per application. So with ANSYS, for example, we improved the performance of ANSYS. With SolidWorks plastics, we've actually got into the solver. It's a thing called thread pinning. Really, no, I shouldn't say really draw. It's really exciting. But the idea of thread pinning is basically making sure that a core and the memory stays locked together. So we're gaining like 6% or something. Well, 6%, if you're waiting for an hour, is time saved. I was talking to a gentleman on the stand, and they basically do some of their stuff overnight. Now, with this sort of thing, with 64 cores, 128 threads, you can do this in half an hour or 10 minutes. We don't want to waste time. We want to be able to do stuff quickly. So the point is we're optimizing stuff to make it go faster. Laptops. We haven't been that well known to making fast laptops. Laptops has not been a thing that we have had laptops, but today we have some very, very new laptops which are coming out, which are a lot more performant, because we have a thing called an APU. So we have a GPU and a CPU in the same die. That saves power because you don't have to do twice as much cooling, and it also means that we can integrate stuff. So we have a chiplet. I'm not going to go into massive chiplets, so we can make things really small on a one piece of silicon. So it's very dull. I don't know if that's just me, but so on the stand we've got ZBooks, and it's like a 14-inch ZBook with 32 gigabytes of memory on board, and it's super small, and it's running SolidWorks with no problem at all. There's a whole range of HP laptops we've got on the stand, so please come and see us. This year, everything's going to change. By next year, there'll be a lot more range of laptops, and everybody carrying around heavy laptops. This is not that heavy, but you're used to these big, heavy laptops. You don't need to do that because the chips, again, are so much smaller. What is powering all this? We have this Ryzen Pro. This is our new fandangled thing, Zen 4, very small, 4 nanometers. It's also got AI built in. So you all see stuff, and yes, we support AI on the graphics cards to do stable diffusion as the demo on the stand, but actually the actual chip inside has a part of it which is dedicated to AI. So the other thing which is important is professional graphics. You have professional graphics on the laptop, so you don't actually need to go and buy a discrete graphics card in the actual laptop. You can, even though these HP laptops offer that, a separate graphics card, the one that's built in actually has professional graphics. So you can run all the certifications and everything is there. To give you an example, the one in the small laptop, in both those laptops, this is the built-in. So you don't have to actually specify a separate graphics card. The built-in one is performing as good as the NVIDIA 2000 range of graphics, and that's just built in. So that's basically a very cheap config for a very, very high performance. And it has all the certifications, all the relevant stuff you need to run your applications. One of the things that I do, the thing with this is you have to set how much memory in the actual graphics card. An example is SolidWorks really needs 8 gig minimum. To run SolidWorks properly with high performance, you need to have 8 gigabytes set minimum. And obviously it works on 4 gig, but 8 gigabytes is the minimum to actually get the high performance mode in SolidWorks. And the easy way to do that is to go in the BIOS, This is an example in Lenovo, and set it to 8 gig. Why? And you might say, well, isn't that automatic? It is automatic for DirectX applications, because it's Microsoft. But OpenGL applications from SolidWorks, Siemens, whatever, they don't understand that because they're OpenGL. So they're not going to actually tell Microsoft Microsoft operating system to say, look, I'm going to change the graphics, so you have to manually set it. Big change. I've seen people change this and they go, oh my God, I can rotate this at 30 frames a second. That's the big difference. Simple setting in the BIOS makes all the difference. If you want to, I can give you examples of this as well. But that's the setup on the config. You need to make sure that's set up. Most laptops work out the box straight away, but things like that need to be set. Inventor has hardware ray tracing built in nowadays. Again, it will use the APU power to make that work. I talked about Ryzen. Ryzen AI is AI that's built into the chip. So the chip inside there, we bought a company called Xilinx, and Xilinx actually put a dedicated part of the chip for just for AI. Now, we all know that AI is interesting. There's lots of benefits for AI. I quite like this. This is quite funny for me. There's Windows Studio effects. So you can be watching, you can be actually on a video camera, someone on a Teams call, and actually basically puts false eyes on you, so you look like you're looking at the camera all the time. So you can be looking down, typing away, and everybody thinks you're looking at the screen. The power of AI, what it can do for you. So, but this is the world this is the world we're facing. We don't, whether it's there or not, this is the world we're going into. Stable diffusion, we've got some new stuff on stable diffusion. This is basically creating some random cars, very ugly cars, but that's using 44 gigabytes of the graphics memory. That's how much it needs to do this stuff for AI. We've got all the performance to do that sort of stuff as well. Okay, so I'm just going to quickly go through. We've got lots of high-end graphics cards to do all the VR stuff you've seen before. We've got a very happy SolidWorks user who loves the stuff and does lots of renderings. So he was on the stand at SolidWorks World, and we've just come out with a new range of cards. I don't need to go into details because I'm between you and lunch. So the point is, come and have a look at this. Come and talk to us on the HP stand. We've got these new laptops. You'll be surprised how powerful they are and how small and light they are. I've got to go through all of this stuff to make sure you read all the end notes to make sure I'm legally covered. Okay, you've read all that, and you read all that, and you read all that. Appreciate it. Let's have a nice lunch. Thank you.